A very good day to you all. On behalf of the World Resource Webinar, I would like to welcome you all to this session and yet another session that we all are looking forward to, hosted by World Resource Webinars, a public member of the World Economic Forum. I would like to introduce myself as Priya, joining you all from Ireland. I am a HR by profession, having a flair for technology currently, and in the process of upgrading my knowledge. I'm associated with GPS Renewables currently as a senior HR business partner. GPS Renewables is a clean tech firm where we support sustainability-based projects. I'm here all excited to be part of this workshop to facilitate the session and learn from some of the experts on the topic of the day, artificial intelligence. Today's workshop on artificial intelligence will provide us with a learning opportunity to keep abreast of the technological advancements happening in the Industry 4.0. We have 4 dynamic panel members who will be sharing their industry experience and expertise with you for a deeper understanding of the current developments and opportunities in artificial intelligence. It's a request, please keep your mics muted during the presentations to avoid any disturbances. There will be a question and answer period at the end of each presentation where you could raise your hand or type in your chat and ask your queries or any comments if you would want to share. After a session, we will also have the certificates shared to your email ID for benefiting the participants who have been part of this session. You could write to worldresourceswebinar@gmail.com. I will also share the email ID in our chat in case of any further queries after the session. So let's get started for the day. Moving on to our today's session, we have Dr. Umachandran first to share his knowledge with us. To most of us here, we do not need an introduction about him, but to benefit those participants who are new to this forum, I'm sure I can say that Dr. Krishnan is a brain behind the session of this organization. He has 30 plus years of industrial experience and is currently associated with Nelcast as general manager, spearheading its organizational development activities. He started his career as an engineer at English Electric and moved into talent management, working with some of the leading manufacturing companies like Hindustan Motors, India Pistons, L&T, to name a few. In addition to this, Dr. Krishnan has associated as a faculty with renowned institutions like the Madras School of Social Work, supporting a twinning MBA program affiliated to Arizona State University, academic staff college affiliated to University of Madras, Amrita School of Business at Coimbatore, and as a faculty for information and communication technology at Macquarie University, Kampala at Uganda. Today, he'll be sharing his insights on the topic, evolving process artificial intelligence in manufacturing industries. Sir, over to you.
Thank you. Thank you very much, Priya. Let me share my screen and start my talk. Right. Okay. Can someone prompt? They can see my screen.
Yes, sir.
Thank you. See, good morning. Early morning to people joining from West Indies and people across India, US, Europe, and down the earth. So friends, happy to be with you for sharing my knowledge about artificial intelligence. This is a decade-long kind of an experience which we are sharing through many forums, and surely we are confident that you will be enriched by this process. See, the topic on which I'm going to talk today is going to be on evolving process, that is the AI process, artificial intelligence process in manufacturing industries. I'm Dr. Umachandran. I've been told much by Priya. So this contains whatever I'm going to share with you during my talk is on the genesis, neurons, explicit and hidden, and how artificial intelligence is going to be in an IoT environment then artificial neural network designing, then we go on with coding a neural network, then the priority tools, which is happening in manufacturing. You need not worry about the algorithms. I will tell you where you can buy it and use it directly. So enough of marketable tools are available. Then I'll pick you on to what is a case study we have, and then I'll go with a conclusion. This is how the total structure of my talk I've designed it through. Okay, now getting on to the first part. See, we are going to mimic a brain, a human brain. Suddenly, if you want to get intelligence into a computer, which is akin to a human brain, it is not as easy as we think. Because, see, human brain has a lot of wishes, acceptances, rejections, many things happen in a human brain. But when it goes to a computer just goes along with your algorithm and your data on which it is being fed. So your algorithm and the data should be complex enough to understand. That is where the first part of the structuring of ANN or artificial neural network towards AI, artificial intelligence, requires you need to structure it properly and synapse the weights, where the nodes of the neurons are joining. You should know how to join it. That is where the more important problem comes, and for which we are going to take a lot of inputs from the perception. That is what we see, what we hear, what we feel, all other inputs towards our cortex of problem analysis and the solutions, and then taking it for a control. This is how the ANN is going to be developed, and I'll push you on through the total process of how it is coming up. See, artificial neural network depends on the neurons. Neurons, a biological neuron has a different composition. It is a live aspect. Whereas when you are creating it in the computer, it should also become live and should be comparable to your analysis as a human. So more of the thing, what we want from a ANN or a neural network or from an artificial intelligence is, it should have unsupervised learning. Learning can happen by person, as a biological person. But when a computer has to learn by itself and control by itself, then the theme of the complex aspects that needs to be controlled is the more important part in this part of ANN design. So if you want to make an unsupervised learning, then there is no teacher signal. That is, you don't get taught during the process of analysis, but an error information and clarification should happen. So these are the bases on which the total artificial intelligence comes out to work with. Here, many of you are into computer science, and how there are neurons being associated with artificial intelligence, and there are layers of neurons which are called as open or input layers, and then we have hidden layers and output layers. I'm not going to get into all these things because you all know. But when it comes to a system, a device or an equipment or a machine or whatever gadget you are having, if it is to work in association with your thinking, then it is not required to do an arithmetic sequencing or computing. It has to do what is required. It has to be classifying it and then associate the classifications and then do a reasoning. So ANN is not a complex part. ANN is the part of using the smart thinking in a human being. That is where classification, association, and reasoning are the three important requirements when you want to get into AI, artificial intelligence. So the solving of actual problems, it goes on in a multi-layer feed-forward network. It means you have an input, it goes to a hidden aspect where it gets analyzed, and then it is triggered to the output, and it is checked, and then it throws out. So when you get all these channels of neurons connected, and then when it does it, you need to know where you can handle the bias and where you have to handle the errors. These are the two important aspects when you do an ANN design. So the complexity is not as much as we think. It's only deciphering what to do to a computer and how to link it. So it's an easy job. It's not complex when we understand what is the real requirement. See, here in deep sensing, see, when we want to have the machine to understand what is vision, what is smell, what is speech, what is sound, what is touch, what is taste, then you need to have different sensors for it. Those sensors are the ones which is picking out the signals. Like for vision, we can have CMOS, the complementary metal oxide semiconductors, which can be either of a monochrome type or a color type. So accordingly, you can visualize for your real network that needs to become intelligent. If you want to use smell-oriented signals, then you can go for volatile calorimeter, infraspectro, gas chromato, or mass spectrometers. And then you link it. Then speech, speaker, dependent or independent, sound, acoustics, pressure, amplitude, whatever it is. The touch, the capacitive touch, what we have in our mobile phones, or resistive. The earlier models of smartphones had that kind of a touch screens. And then the taste, chemical, microbial, pH, or titration. This is only illustrative. It doesn't give you the whole sum of what are the sensors. Sensors are also in combination. Vision smell, or vision speech, or vision sound, many combinations. You have sensors available in the market. Whichever you can think suits your kind of a project, you can pick it and do it. But deep sensors are not only perceived, it is also to be helped with a lot of tools, which we call it as OKVES tools, smart tools. Like we are intelligent by being organized, where we look into the calendars, schedulers, reminders, etc., and we are organized. Similarly, a machine, when it can get linked with organizers, then it will also get matured to behave in a position where it looks to deliver as intelligent as we are. And when we don't know something, we look into knowledge sources like Wiki, Google, or any search engine browsing aspects. Similarly, a machine, if it can pick up the knowledge, what is it required, then it will also become so intelligent to perform. Then the visualizations, see, many a times we are driven by charts, maps, graphs, dashboard, anything, so that we change our speed of working, or change of our approaches. All these things, if a machine can take, it is also a visualization. In addition, human beings have this expert opinions. Similarly, if a machine can also link with the experts to get astonishing breakthroughs or new pathways for surprising researchers or anything of that sort, then this machine will also become more human in thinking and intelligence. In addition, we are not saying everything by words or actions. We have many things as a physiological process. Like, for example, we send signals, signs, sounds, gestures, many things we have. If similarly a machine can understand, see, if your eye movements can be understood, there is a sensor called electrooculogram, which can measure your eye movement. So where your eye captures, which product gets more noticed, and where you are spending more time. If these things can be understood by a machine, then it can also be intelligent to throw you out the next time what you want to see. Similarly, encephalogram, your brain activities, if it can be handled, then we have sensors for it. Then the dermal activities, skin is the one which does not lie in human beings. If we like, we don't like, everything is reverberated by our skin. This is called the dermal activity. For all emotions, if we can sense what a human being feels, then the dermal activity sensors can help you out figuring out the required thing which a human being can take up for his project. Then the myogram, the facial muscles, facial reactions change. Whatever we feel, it shows first in our face. So how this can be checked? These things are the ones which are smart tools along with the sensors that can help us to identify the signal. Once we know what signal we can capture, then we have done the best part of our design. See, when it comes to IoTs, see, raw measurement, when a signal comes out of a sensor, it's a raw measurement. So that has to be converted into an electrical change. That's called the transducer. And once you change it into a transducer elementation, then you have to convert it into a binary action where the computer can understand, which is called the data. The data now is far-fetched. Like, you have a lot of data, which is called the big data, which has pattern space. Like, there is a lot of logics going into it. There's a lot of opportunities getting into it. There's a lot of things that can be patched up into patterns. These patterns have to be identified for the feature extractor, where you identify the features. Like, there are a lot of human beings around and you want to pick one person, that means you need to have that feature put into your ANN so that it can recognize that features. So you need to map the feature space and then classify it. Classify is nothing, classifications. Whatever we group together are classifications. So these are the basic things on which any artificial neural network aiding for artificial intelligence performs. So these inputs are nothing but data. When it is fed into a neuron, all data cannot give you the right kind of an activity which a neuron has to respond. That is where, like a brain, we see many things, but we don't respond in the same thing for everything. So at times we control our behavior. We know what to do. Similarly, a neuron has to be taught. This is where the learning and training that needs to go on in the neuron. This is how it happens is they call it as weight. They give a weight to a particular input variable. And that weight, every time it will not be same. It will change. That is where it is called as bias. So when the neurons, which are channelized for the hidden layer to process an input, then you need to give weights, and those weights, though we have calculations, the weight value and to input value, you need to sum it across all along the neuron chain. And then if you find there needs to be some correction, that is like bias. Like many of us are teachers, we know many students who are really studying well. Sometimes if these one or two are failing, we give a grace mark and pass them. So similarly, a bias is always there in the network that needs to be trained. A computer has to be trained, otherwise it will not fetch out the right result. So as it progresses through the weights, which are, this is the supervised part, which I'm telling you. But what we want in ANN is an unsupervised learning that needs to happen. So as we go through these aspects, see, artificial intelligence is a wholesome or a set which comprises of a function of machine learning and deep learning, which are interconnected. See, how is it interconnected? See, if you have a machine and you connect it with a cyberspace, that is a computing part. So the computing part enables the machine to be worked in a virtualization. So through internet, you can control the machine, but you need to have signals. Signals is the one you get in from your IoT. So these sensors, or which promote the signal activation in IoT, should have a reflex towards whether it should be a machine learning or deep learning. To clarify you further on to easy understanding, machine learning is nothing but it is user defined. See, for example, you go into a room and you like a particular temperature to be maintained in that room, you can easily give it. The machine can understand as you clock into your room, you get into that kind of a temperature. But deep learning is, if you are not well to use that same temperature, it should be high or low, then that kind of an aspect should be measured, and that being given to a machine is called the intelligence that goes on through this kind of a sensor. These sensors are the ones which is going to prompt you for devising a better kind of environment on which you can prepare your machine to really actuate its sense in an intelligence aspect. Now coming on to IoTs. So you have a lot of sensors. These sensors have to signals spike out. And as they spike out the signals, you capture it, that you get it from any of the waves, like it can be a radio frequency or a near field device or a Bluetooth or a Zigbee or whatever it is. You get all these sensors, signals, and then you sense it, and then you need to communicate it to the faraway location so that the machine gets actuated for your change. So this can go with your mobile technologies, with either with a 5G, 4G, or 3G, provided you have a hybrid network with a near network function virtualization or your SDN. So based on which the data in the server is being used for this artificial neural network. So it's, each of these areas are specializations by itself. So don't worry if you don't know many of these things. You need not be a master in all, but you should know what has to be picked up. Now our main theme is, getting you all into what is an artificial neural network and artificial intelligence. So now coming on to the machine learning. Machine learning, as I said, it's a machine input which goes for auto programming, where the machine has the ability to learn and experience from its own experience without being programmed. So that it's a linear perceptron. It goes on with a flow on a linear scale. It has the following modules. It has an interactive aspect. It has features, data mining, and chatbot. So you see a lot of graphs, maps, and charts, which can give your inputs to your machine learning aspect, algorithm, and then model it into a time or a deployment. And then you use algorithms, hyperparameters, classification, regression, cluster analysis, anomaly detection, or whatever it is, time series, or whatever it is. And then you get it to a voice or a text so that the person who is going to get benefited by this machine learning goes for a change. So this aspect of machine learning these are all trivial or the basic aspects on which you have to create an intelligence network. First, we need to understand what a human intelligence is before we get into a computer required ANN. Human beings, as I said, we respond to a stimuli or a response, something which affects us and to which we are responding. Earlier, it was known as SOR, stimuli, organism, and then a response was there. Every human being, we are like any other animals, we behave when a response to it can be positive or negative, depending on how we take it up. That is an organism. So a stimuli affects an organism and then a response comes. But later, as we grow up and we learn certain things, we go on for a SOBC, stimuli, organism, behavior, and then consequences. So if a consequence is going to be negative, then our behavior is tuned. So our intelligence is tuned. If a consequence is going to be positive, then our behavior is going to be different. So similarly, we have to model our ANN in such a way it takes care of SOR or SOBC. And then we collect the data, process the data, quick response, and decide. So for this, there is a lot of meticulous smart aspects, that is detailing action, careful attention, application of learning, everything has to be picked up before we venture into doing what a machine is required to help us with. Normally, you would have seen artificial neural network has a lot of neurons connected through the nodes. Point of contact is nodes. That's the synapse. When you have an input to a neuron, it processes as the node connects to various neurons. The process goes on with various neurons, and the output then finally lands onto the triggered output. The total final output comes. When there is a similarity of the output to the input, then we say the ANN is functioning. So we need to identify input properly. We need to identify the output properly. But to create this network, what we have to do is, once we can create it through any kind of algorithmic networks, but we need to also know what the machine should learn and how it should be trained, and the computational power or the capacity of convergence, depending on it should be motivated towards a positive end, or it should be stopping, or it should go for a more of an escalation, where it can go for an exponential output when it can be more than a human demand. So this deep learning is the one which makes to identify similar to our brain functions with our inputs and then process lower layers, which is called as perceptron. These are the basic things which you can understand and go through. But before we go through, I'll give you a scenario like you have a lot of fruits, and some fruits are good and some fruits are decay. Then how will you create a ANN to identify? So to this, what happens is we normally do is we break up it into, take a picture of a fruit, which you're going to analyze, and then put it into a pixel chart where n by n is being identified, and then go on with your textures, colors, or whatever marks, whatever you think for a good fruit is required, and whatever is there for a decayed fruit is to be identified. Then you feed it into your computer, and then you can understand it. But here, what happens is input is there, output is there, but the hidden part is the one which needs to be analyzed and processed properly, where we are going to use Python. Python is the language which we use for ANN, and I'll show you a use case also on this. Before we go on to it, see, in the earlier part itself, I said there'll be an input for which you give the weights, and then you multiply it and sum it out, and then you have a bias correction, and then you trigger it, and the trigger goes for an output. And the output is the one which goes on for a right value that you can decide out of it. But in many cases, what happens is when we start making a ANN or a CNN or a deep neural network, output will be wrong. So there is an error that happens out of the output layer. So how to go backward? See, this process of going from input, hidden, and output is a forward propagation. Whereas when you do for an error correction, it's called a backward propagation, which we are going to see. See, the propagated forward is the one which shows you the output, and the probability is direct. See, many of these things are association, I told you earlier, association, and then you go on for getting them aligned for what is to be logically correct. So you go on for this process But during this, there can be an error. So that is where we are going to identify the output on a probability basis. And if the probability of the output is going to be wrong, we are going to go on for backward propagation. So now identifying how to go on for designing a neural network. See, the weights denote the importance of it, and you readjust the weights for each of the inputs till the error is minimized. But every time you cannot keep on reducing. So because it goes on for a lot of iterations. This is where the skill of the neural network expert is required. When they are in a position to identify what can be the problem in the input stage, then the output stage can be rest assured for having a maximum kind of a acceptable output. See, this is where the CNN comes. See, many a times when you take a picture of a fruit or whatever it is, and then you go on for an analysis, on a real time, people or fruits or things, they don't be on the same shape. They just change their positions. So there'll be a lot of convolutions. This is called the CNN. They don't take a static position. ANN is static, whereas CNN is, there'll be a lot of groupings. There'll be a lot of same people in this a different class. There'll be different sizes. There'll be overlapping. There'll be something which is partially visible. There'll be, looking upside down, and many kind of orientations they will come. So these are called the convolutions that need to be taken care. For a CNN, same kind of a realization has to happen. Like, you identify the object detection you've done, and then you do the instance. At this instance, where I've captured in my picture, this is the positioning of people or fruits or animals or being done, and then you classify it. Then you create the architecture where you do a predictions, box prediction. At this part of my x-axis and y-axis, this photo will look like this. And in the second object, the same object in a different convolution at this coordinates, it looks like this. Like that, you need to characterize for each of these features that you're going to analyze along with a null object. If it is not there, where it will not be there. So this kind of a bipartite matching loss should be identified before you get into the CNN. Similarly, if I'm going to go on with the other neural networks, there's one thing called recurrent neural networks. See, there's something called a past experience that is also hidden in us. That hidden part is nothing but input from a previous stage and a current stage. Similarly, we don't be static. We move on from one phase to another. So the new hidden will also take care of our hidden and the trained aspect along with the recent experience, which is called the input stage. So the formulation or the algorithmic requirement is you have a HT on a function of HT minus 1, the early aspect, along with your input. So similarly, you need to go on for your back propagation so that over a time, there is a learning that can also happen into the ANN. Then this is the complex part, which is called the generative adversarial neural network, where there are some things like fake. See, when something is really wrong, we can easily identify it. But when there is something created to look like, and then it is wrong, then means it goes for a different kind of a neural network. You cannot do ANN, you cannot do CNN. You have to go on, not only go on with a recurrent neural, you have to get into generative adversarial, because this is a known created problem. So when you know this kind of a population is to be analyzed, then you use this kind of a network, where the fake samples are fed into a generator, and the generator gives you the right ones as well as the learned N2 part, the wrong ones, of which the output picks up the G1, that is the right one, and then it classifies it and sends it out. But there will be a discriminator where there will be a lookalike which needs to be identified. So there should be, you should not reject the real sample. At times you have a note which gets clumsied and it looks like a fake, but it's a real note. So a real note cannot be thrown out when you're going to analyze a real versus fake. So you need to identify where the discriminator loss will come, and then you need to train it. And the generator loss has to be weight. That is where you give the weight for adjustments, and then you classify it. This is how the generative adversarial comes. See, all these things are nothing but, you have a machine which can do its work, provided you create an automation to it. And at the same time, if you want to create a kind of a intelligence to it, where your cyber part also works into it. Your cognitive parts works onto it. You need to give inputs of SR, that is stimuli response. You bring in an intelligence. You see to that meticulousness and the smart thinking is already captured. Then you have a sensor to give you a deep learning input. Then you have a cognition correction that can go onto a machine so that the machine evolves. So if you want to get a machine with an intelligence, it goes for a lot of iterativeness that can really pick this machine to become really smart and intelligent. For this, we have cognitive correction using big data. There are a lot of data when you warehouse it. You can either use it or misuse it because it's all people oriented. So when it comes to computing, people can misuse it or even manipulate it. You should know which to be taken. And then when it comes to engineering, it can be either manipulated or pushed out as if not known. So a lot of things during our data mining can aspect. So you should know which is logical, which is pattern oriented, which is opportunistic, and which can be hacked. So the right data is the one which needs to be programmed into our intelligence aspect. So for coming on to this, any ANN or any artificial neural network will have layers, input, hidden, and output. And in forward propagation, all these neurons which are channelized for different neurons of hidden layers will have a triggering part to the output. This is where the last aspect, output should be right. If it is having error, then you need to go for backpropagation. The backpropagation is nothing but you have inputs, you have desired output, then you model it with a weight, and then see whether there is an error which is being minimized or maximized based on the square error. I'll show you how this can go on. Learning for any human beings or for a machine can be on 4 forms, like either supervised, unsupervised, reinforced, or self-learning. It's nothing but you tune your machine or your gadget or your device so that they take care of the activity, they adjust and then apply. So this is the output that is required during an intelligence being derived into a system. So when you're going to get into this, the square error is the one which you need to check. When the square error drops, as it drops, the weight keeps on increasing. When the square error comes to a minimum, and that point is the one which you need to pick. And again, when the square error tries to climb up, as the weight increases, you should stop your programming. So there are limits to your Python programming on where you need to put your control limits. Similarly, a square error can keep on dropping and the weight can keep on going down. Even after the weight still goes down, the square error will improve. At that point of the parabola, you have to control where the minimum square error comes and then take the limits for this kind of problems. So now coming to the PyCharm. PyCharm is nothing but it's a Python programming, which is an IDE, Integrated Development Environment. First, more important part is when you listen to this program, remember these 5 libraries: Matplotlib, TensorFlow, NumPy, Pandas, and sklearn or sklearn, whatever it is. These are the 5 libraries you need to create because these are the libraries on which you're going to feed the data. And this is the data which is going to create or make your algorithm come out. So what for these things are? As we go on, this Matplotlib is for visualization, to understand the problem structurally before coding. So Matplotlib is required. TensorFlow is for your deep learning neural networks. How you can take different sensors inputs from your IoTs and then connect it. And so you make the string of decision making. NumPy is your vectorization or your numerical value for your Python. It can be used for indexing, mathematical functions. It can have a distributed library. It is used with a GPU. It can go on with your algebra routines. It can go with your Fourier series or your random number generalizations. It can get along with hardware and computing platforms and all these things. For this, you need to know about NumPy, and that should also be getting into your coding, and the Pandas to go on with your CSV files where your data is there. So those things, along with the label encoding, shuffling, or train, test, and split, then you get on the scikit or your sklearn to help you. See, this is the things on which you need to feed your data. If you feed your data, then your algorithms, which I said, ANN or CNN or RNN, or your generative, adversarial, any which you require for your, problem, that is the one which is going to give you the support. There are many deep learning networks and look into it. TensorFlow, I've already told, and it is required. It's nothing but it shows you a data flow with a differentiable auto differentiation. Similarly, you can have a PyTorch, which is coexisting with your code support as well as your modeling. Whereas in our model earlier, I said about the modeling, the visualization. So I use TensorFlow. Whereas for PyTorch, which if you want to have coding as well as modeling, then you can go with PyTorch. Then all similar is the Theano, where it's a modular code, where it is completely for a defensive check. It is not for programming. It is if you have done a deep neural algorithm, and if you want to check, use Theano. Theano is the one which can help you out to find out whether what you have done is right or not. And the Scikit is nothing but I told you about the sklearn also. Then these are for you shuffle or go with your data in different patterns in different forms. You can do it. Then Keras is a Python API, which is again a high level one, which is still evolving. So you need not worry about it. Think about these 4 or 5 algorithms which are available in the market. Now the epoch, the iterations, because we don't know how much we are right. Every time we have a data set and we pick a data set like a specimen. If you want to remember what you have to do, you think about what we have in our space, SLV3 or whatever it is. Where we launch a rocket, like you have a specimen, what you have to do, you have to have a payload, like you need to identify the patterns, then you have a features, labels, and variables. These are the epochs on which the total iteration of deep learning happens. So once you know what it is, then we can understand what is happening in an objective for a manufacturing. Manufacturing requires a lot of priority. I'll rush through because you can easily understand the basic, and then you can pick up inputs from the manufacturing part. There's a lot of priority which needs to be given in manufacturing process. There is consumer who has to be handled. There is competitiveness for your existence and for your growth. And then there is quality, urbanization, economy, all these aspects that needs to be taken into a manufacturing parameter. In short, AI for a manufacturing is nothing but it takes into consideration big data. You create an algorithm and you go on with your past experience to either adjust, amplify, or scale. This is what an AI is in a numerical format. So now going up, so priorities. See, I said priority, there are a lot of tools that is already available. Like for example, Google ML Kit is available. You can go and iteratively learn, or OpenNN, which is an analytical tool for graphs, maps, charts, and a water algorithm, H2O, they say. It's a standard H2O, or a sparkling, if you want to have a paid kind of customized output, you can get it through. So all these things are for predictive, risk, fraud, insurance, advertising, or for consumer customer intelligence. Like, see, for example, we have a lot of automatic machines now, and these automatic machines have a lot of sensors, and they go on with a lot of data, like from ERP it takes or from operations it takes. So that if you want to create an intelligence into the machine, then you need to see that, figure out what is the reliable state that requires and what is the variability that needs to be taken up and how the market demands are to be worked out. Similarly, a consumer is the one who pays for your machine or your output or your product. And so he is the one who has to be taken for being satisfied for the delivery of service. So there are a lot of algorithms like ChatFuel, you have ADA, it's a no-code chatbot, or Albert, you have, all these, it's for interacting with your consumer or a customer. It can be a chatbot connected to your website or your social media. For example, Panasonic, if you go, they already have ChatFuel into it. They have the chatbot into it for a customer service. When you buy a product from them, you will automatically get a chatbot linked to your WhatsApp. And then many of these home appliances people have started using for getting more data, and they keep all the data with them for their future requirements also. As we go through, the next part is the HR skilling, because in a manufacturing setup, you need people. And people flock from one organization to another as they get more paid and for their mobility of their advancements in their career. So there are algorithms like Skillate, Talenture, Pymetrics, and all these things where machine can do the AI JD, job description, and it can mask your personal information so that the interviewer does not have a bias in selecting you. So the right skills can be identified and it's automated. So you need not worry about whether there is a bias in the selection process. Then the Talenture goes with ranking the thing, then it goes with employability parameters, your business relationship, and then associate your candidature for taking for a bigger positions. Then you have this. Then you have the Pi metrics where you create a lot of games, which is like a game. You send it through your mobile link and they open it. You can identify how cognitive they are, how emotional they are, how logical they are, and all these ethic fairnesses can also be derived in the human requirements for an organization, so that you allay the fear of job loss. Tomorrow, if somebody is going to be in the organization or out of the organization, they know why they are for and how they are important to the organization. Competitiveness, like you don't exist by yourself. Organizations depend on many other organizations so that they have to compete and perform. So as they perform, what they have to do is there's a lot of goals that needs to be required, which is called the primary goal or secondary goal towards the operative excellence, like OE, your original equipment efficiencies, productivity, rejections, downtime, receivables, EBITDA, potential losses, or whatever it is. There, the cleanliness, safety, and the product identification of the organization is virtually accessible, and it sustains over the VUCA. The volatility, uncertainty, complexity, and ambiguity that is available in the manufacturing setups. Next to competitiveness, you have the quality. Whatever we do should be of quality, so it's assured. When we use ANN and all the stuff, you need to have assured output that is delivered by the organization, where you have simulation tools right from the input process outputs, and then you have SPC, SQC, so that your process controls and your quality controls are taken care by the machine itself. And then the surface finishing, mounting, fitments, limits, everything goes on with your tolerances and allowances that you suit to your customer requirements. So it helps up in scaling up the organization's position and then deliver. So these kind of algorithms are already available in the market. Then going on to the urbanization. People want to be happy, they should be safe, they should be secure, for which the environment is the one which needs to be protected, where air, water, and soil quality is measured. There are algorithms for it. The safety of people, children and women and all people have to be protected. You have travel identifications, requirements, and facing suitability for picking up as per their requirements. In addition to tackling the traffic aspects, are living in with innovations. These are AIs which are also available. So you can pick those algorithms and suit it to your problem and create your network. It can be ANN, CNN, RNN, or your generative deep adversarial. See, finally, going before, the economical part is more important. You can be, intelligent, but is it required? So how much it is required for individuals? There are algorithms to suit individuals, groups, savings, insurances, luxury, legal, all these aspects, along with your fintech and the capital operations, suiting to individuals and communities. These are the algorithms which are used in manufacturing. But before I close, I wish to show you something, a use case on a warehouse. A warehouse is an area where manufacturing outputs are being stored before it is reaching to the customer. Where you manufacture, you stock, you sell, and once it's sold, that space is to be refilled with another product, and then it is sold. So the sell, refill, sell is the cycle that needs to be taken into consideration. But at times, refill will not happen because there is a stagnation of product. So when a stock stagnates, then your SKU, the stock keeping unit, should be readjusted. For either you remove the product from the space so that you can keep some of the product, and then you keep on making your operation to be on a maximization process. So you need to do delisting. So if you want to create a ANN or an artificial neural network or intelligence for delisting, it should not be human oriented. But learning of this will be assisted with human. See, this is where the cutting edge comes. On-the-shelf presence should show efficiency and effectiveness, and it should also help your portfolio, that is the brands and products, to have the process of delisting a non-moving aspect, because when an inventory gets clocked in, then you don't get more of money. So you identify which is not moving, and then you have to create a artificial intelligence. This is called the granular assessment. What they do is the faster, better informed decision. If a supermarket or a stocking aspect happens, then the retailers are benefited, the shoppers are benefited. Your organization also takes up into a spike where you delist, watch, and grow. So the moving items are the ones on which you have to, as a shop owner or a business owner, when you want to trade in, you can invest. You need not buy something which is not moving. So you can make an assortment of what you need to pick and use. For this, the optimization aspect comes in, where this is a high data-driven platform which goes on with ANN aspect, where the low ranking SKUs can be, if it is just launched, people may not know, so it has to stay. You cannot just throw it off. Similarly, when it is getting established, you need to give it time. You cannot say the computer cannot say that it has passed up more time, so I'm just removing this. No. So based on the time, cost, and capacity, traceability of the product, control of production, so that the manufacturing need not produce this, then the inventory part of it, space, waste, and transport, all these things have to be optimized on your data when you are feeding it into your ANN. So when this data intelligence comes up, what happens is you have to accurately handle with insights and actionable requests for the data. Just like that, you cannot say I classify it and then I'm throwing it out. No, you have to classify it, use it properly, and then throw it out. So you need to know based on the segments of categories, customers, brand, and channel from the big data. You create a visibility both for the leadership and for the governance aspect with both your customers and your organization, and then take it out. Finally, to close, this is my last slide. Ultimately, any intelligence is not only data, it is not only analytics, it is not only information, but for a decision. So if you want to have a decision really packed up by your artificial intelligence or ANN, then you need to look into service and support. Because tomorrow, people are the ones who are going to buy it, use it, and then rebuy it and use it. So your customer experience takes a point of requirement, then marketing, supply chain, operations, safety, quality, insurance, learning, and transportation, all are linked into manufacturing. So manufacturing cannot have a one set kind of a algorithm. It goes through a lot of iterations before it really comes up. Thank you very much for your time. Over to you, Priya.
Thank you, sir. Thank you for that extensive presentation. We really had a deep dive into, I think, multiple topics within artificial intelligence. Okay, we open the time slots for any questions for the participants. Please make use of this time so that Dr. Krishnan would be in a position to answer the queries within the short time we have. Okay.
If there is no question, I'll wait till the last.
Yeah. We could also have it posted in the chat. Okay.
Someone has typed out, how can we compute complexity in DeepNet in terms of big O? What do you mean by big O, sir? Can you read out you can unmute and you can read out also so that we can understand.
Hello, good afternoon, sir.
Good afternoon.
Sir, big O means in design analysis algorithm, we learn about the complexity, like time complexity, space complexity, omega, big O, omega. So sometimes someone asks, how can we compute the like VG16, VG19? How can we compute the complexity in terms of big O in all these nets?
Okay, good. Now I understood. So you have some kind of a parameters for which there are limits, and these limits have to be controlled as per your requirement. It can be metallurgical oriented, it can be user oriented or machine oriented, whatever it is. So if you take a kind of a parameter, the limits have to be based on your square error and weight. Here, when you make a kind of a algorithm, on any network, it can be on ANN, CNN, or generative adversarial, but for you, it is going to be only on ANN. For your ANN, the weights which you assure through different neurons can be controlled by your square error over your weights. This is where your square error weights are less, pick up that area as the point of acceptance. So your input can be anything, but your output, when it is being triggered, your square error should be minimum compared to your weights. And that point of convergence is the one which your algorithm has to pick. So it can be onto any aspect. It can be onto your metallurgical aspect. It can be onto your heat treatment aspects. It can be onto your dendrite formations in your material aspect, whatever it is. Whatever you can identify and you want to use, it should have a minimum square error over the weights which you are going to apply. So the machine can easily do it. See, for example, you have a calculator, and for a calculator, you can measure weights which are in kilograms, which are in grams, which can be in micrograms, anything, because the input to your calculator is going to be on a numeral scale. Similarly, the ANN is going to take only your numeral scale, and the expert of understanding is going to be still with you. You can give the units and the limits. So the same calculator can be measuring weights. It can be measuring rupees. It can be measuring heights. It can be measuring weights. It can be measuring many things. But the numeral is the one which the computer takes. The numeral is the one which your calculator takes. Similarly, your ANN is going to take only the numerals and it is going to pass through, and it is going to work only on this concept of square error to be minimized across weights. That's all.
Okay, thank you, sir.
Thank you very much. You can call us if you really have some problems so that we can help you.
Okay, sir. Thank you, sir.
Thank you, sir. I hope, I think the explanation was really in depth. Thank you, sir. Okay. Any more questions? We have another few.
Hello, Dr.
Yeah.
Priya, Dr. Krishna. I put a question on the chat.
Oh,
Not
sorry.
sure how
Yeah.
relevant it
Can you
is,
read
but
it out?
Sure, I can. So how can I use artificial intelligence in marketing or purchase funnel or classification of inquiries that I'm getting?
Right. See, Padma,
what kind of data?
see, you should be a management person also. See, data we have extensively in marketing, finance, logistics, transportation, etc. But what we need to do is we need to first classify it. The more importance is how we classify the data and how we associate the data. And third is the reasoning we are building in. These are the things which are going to go into your algorithm. This is where the expert has to really tell. See, when you are classifying, see, for example, you take a marketing tool. Marketing tool, it can be spread either across a geography or based on your consumer preference or based on your consumer affordability or based on your mass actualization or premium segments. It can be on many classifications. So how you classify each of this, and then you associate various parameters into it, and then how you want to get a logical sequence out of it. That is where the marketing or any problem for that matters. We cannot refer our house with our neighbor's house. We have to refer our house with our requirement. This is where the organization has to take a clear clarity of how we want to go, what we want to do. Our intelligence is based on our data. So within our data, what we are going to do and how we want to use it. This is where we have to push and serve.
Thank you so much.
You can call us also anytime when you have difficulty.
Okay.
Thank you.
Thank you, Padma. Thank you, sir. So,
We'll go to the next person.
yeah, we have, okay. Okay, moving on to our next expert speaker for the day is Ms. Priya RL. Welcome, ma'am. Due to our constraints in time, I'll have to cut down few of her expertise. So I'll give a quick introduction about Ms. Priya RL. Ms. Priya RL is currently working as an assistant professor in Vivekanand Education Society's Institute of Technology at Mumbai. She has over 18 years of teaching experience for undergraduate and postgraduate students of computer engineering and information technology disciplines in different engineering institutes. She has obtained her master's degree in information technology engineering from Mumbai University. She's also worked as a software engineer in various organizations. She has more than 30 international publications in various reputed journals, books, and conferences to her credit. Her research interest is more into artificial intelligence, Internet of Things, software engineering, next generation network, and machine learning. Welcome, Ms. Priya. The floor is all yours. The topic Ms. Priya would be covering today is script recognition using NLP. We're waiting to listen to you, ma'am.
Actually, she is having some network issue. So can we move on to the next and we can ask her to continue?
Oh, okay, sure. Thank you, Abirami. Thank you so much for informed. Yeah. Okay. So we will, the next person we would be having would be Dr. Comfort Olebara. Dr. Olebara is a lecturer of the Department of Computer Science. I would like to welcome her to this forum again. She is part of the IMO State University, Owerri, Nigeria. Her academic interests include social media and its related issues in communication, data analytics, cybersecurity, cloud computing, artificial intelligence, and its subsets. Doctor has contributed to many local and international workshops, conferences, and journals. Dr. Olebara is a member of Association of Computing Machinery, Institute of Electronics Engineering, and Computer Professionals of Nigeria. Currently working on artificial intelligence blending for smarter systems. She's a co-researcher in TED Fund project that seeks to virtualize computer science laboratory, practical teaching for National Open University at Nigeria, with roles of need analysis and cloud service provisioning. Doctor, requesting you to throw some light on the topic, AI blending and smarter systems, please.
Good morning from Nigeria.
Good morning.
Permit me to share my screen so run. Okay. The topic actually has to do with bringing in various AI components, AI resources for making smart systems smarter. And by smart systems, I mean IoT systems that are linked up to a network. Okay, so AI has been discussed and going without saying because we are
okay, thank you. Thank you for going on mute. Ma'am, you're on mute. Yeah.
Hello.
Yeah, we can hear you, ma'am.
Okay. Now the workflows are the machine learning, computer vision, natural language processing, conversational AI, and many more. So we have a demo. I'm going to just throw light on this and move on. Multiple components of AI can come together in one solution. We have the Alexa, where we can actually use the conversational AI to activate devices and then make these devices send telemetry to the cloud and actually analyze the telemetry, the data sent to the cloud, and then return feedback from the cloud. So we have device to cloud, we have cloud to device for various reasons. For device to cloud, we'll be looking at how data is sent from devices to the cloud, and then for storage, for analysis. And then the analyzed data is for insight gaining. Now, gaining insight is for the purpose of enhancing the capacities or the capabilities of enterprises. So smart systems are devices that combine the activities of data processing, sensing, actuation, and communication. And they stay together in a network. To connect to the cloud, they use what we call IoT hubs. The cloud provides compute, storage, and network. And these are the major areas that enterprises invest in. Initially, before the cloud, now that we use the cloud computing, we had server systems. And this server, enterprises can pay for the server without utilizing or without making use of all the resources they paid for. But with cloud computing, you only pay for what you use. You can have the pay as you go. You can have negotiate for a time period and then just pay for exactly what you used. So that's the beauty of the cloud computing. Now, IoT devices can be the sensors. We have the switches, the routers, your home devices like the refrigerators, the cameras, and so on. There are so many IoT devices, each picking different data. Some are picking video, audio, text, and all these data collected are streamed to the cloud. So there is massive amounts of data flowing in from various IoT devices. Now it is predicted that by the year 2025, we will have over 75 million IoT devices connected to the cloud. In fact, I think we've already surpassed that. An IoT device, like I said, will connect to the cloud through IoT hub, and then whatever is connected to the IoT hub receives telemetry or data, and the data must be stored somewhere. So we have inbuilt event hubs, which are like storage points for data. We have blobs and custom endpoints. All these endpoints are storage locations from whatever the IoT sends to the cloud. Now, what has been received in the cloud must be processed, because the essence of sending data is both for storage, for compute, which is like for analysis, and then for inside gaming. So if after storing your data, let's say the blob storage now, any content or data you don't need for now, you can just drop it in the blob storage and allow it to be there. Whenever you have need for it, you go back there and then get, because resources for storage are not expensive. So they allow you to just keep your things so that data will not be wasted. Okay, now, whatever has been sent has to be processed, especially the IoT device stream data. For instance, if I have a blood sugar monitor attached to my system or my body, there will be millions of data sent over a period of time, because these data are collected per second. So the stream processing is an intensive task that has to be taken care of. And then as it is received, it has to be analyzed. So manual analysis of stream data is practically not feasible. So AI has to be involved, training of the data, gaining insights into the data, making the data give the results that will enable enterprises to make better decisions from them. I will have a use case one, that's a blood sugar monitor. The essence of having some of these could be, let's say, for a diabetic patient, having this attached to himself, and the telemetry data is sent. So the decision can be made, okay, at this point of the day, this person has the sugar spiked. And then from that understanding or insight, the patient can be advised, okay, find out what triggers your blood pressure at so and so point of the day. And from that, decision can be made and the health can be improved. We are going to do a demo for the temperature sensor. This is a Raspberry Pi simulated device that reads temperature from the environment. So I'll demonstrate how this works. And from there, we'll now see how we can receive telemetry from devices, analyze the telemetry, and then have better insight into what has been received. Permit me to go on for the demo. Okay. For this, hello, I hope I can be heard?
Yes.
Okay. For the demonstration, I'll be using the Microsoft Azure environment. Firstly, you have to have a subscription. If you don't want a paid subscription, there's a free one available for a beginner. There's also a student version that is also free. But for those free ones, there are resources that you can't really access. So I'm using a paid subscription. And with that subscription, the first thing I would want to do is to have a resource group. So to create a resource group, whatever resource I want, I just type it in the search bar, and then it will look up the resource and pull it up. Firstly, I have to have a resource group. And what the resource group does is categorize or organize all resources that I intend to group as a team. So firstly, I search for my resource group. I'll just describe how this is done. So I've created this already, so I'll describe how it's done, and then I'll use the already created ones. So the resource group is here. Okay. To create one, I'll simply click on create. Okay. So every resource, or be the resource group or whatever you intend to create here, must be created under a subscription. So here I have my paid subscription, and the name of my subscription is Azure Subscription 1. So resource group will be typed like I'm trying to create a new one. I simply type it in here. Let me call it new. You use your own unique name, new resource. But it must end with RG to show it's a resource group. Whatever name you intend to give your resource group, make sure it ends with what? RG to show it is a resource group. Next is selection of a region. Now, these are data centers for storage of whatever you're going to store in the cloud. And it is advised that you choose a data center that is very close to you. For Nigerians, the closest data center is South Africa. So I'll be using data center that is in South Africa, and I have it here as South Africa North here. Okay, so having done that, I'll review and then I'll create. But in this case now, I'm not going to create, I'm just showing the steps for creating a resource group. So I'll go back to my resource groups and select an already created resource group. Yeah, I have a resource group here called Analytics. So that's the one I intend to use for this demo. And every resource group allows you to create other resources. For instance, like I said before, an IoT device you intend to connect to the cloud must use the hub. So under this resource group now, I'm going to create a hub, and the hub will allow me connect my devices to the cloud. And that's it. So I am going to create a hub. So to get a hub, I'll simply, like I said, whatever resource you want, type it in and it will just show you. So right now I need an IoT hub. There it is. I'll select the IoT hub. Now it's asking if I want to create or choose from existing ones. For now, let me show the procedure for creating an IoT hub. Then after that, I'll use an existing hub. Okay. Remember, we created a resource group, and I'm still using mine called Analytics. So once you create a resource group, in trying to create your hub, the resource groups are popped up. Is either if you've not created one, you can create it right here. If you have created one, you can select it from the list. So I have selected mine from the list, and my IoT hub name, I can call it environmental data, NVR data. okay, environment, or just call it weather. Anything is, this here is unique name, you choose yourself. So as long as it's in small letters, or you can, it's not available. If it's available, you'll be told it's available. I'll call this weather hub. Okay, this is available. It's not telling me it's not marking it for me. So I'm still going to choose a region. Remember, I'm using South Africa North. So I'll have to go back and choose South Africa North again for my hub. This may brings your storage location closer to you. Okay, with that, I'll look at what's available in networking. I'll look at what's available in the management. The management of the hub is quite important because this is where pricing comes in. We have the free version, which is the basic tier, basic 1, basic 2, 3, and these are like various offerings. But they don't allow you to do certain things. The basic hubs are free, but there are resources that you can really acquire with them. So I am using the standard tier 1. Yeah, that's it. So selecting what I want, number of the scaling, I'll leave it as 1, and then I'll just go on and create my hub. So remember, again, I have a hub, so I don't intend to create a new hub. I'll go back to IoT hub. I'm discarding the procedure, and I'll choose from my list of IoT hubs. So I'm using AI blending. Okay. Having a hub entitles you to creating a device, like a virtual device, because every device that will connect to the hub needs a connection string. Without the connection string, you cannot connect a device to the hub. So what we'll do is create a virtual device on the hub, collect the connection string from this device, and then use it to connect whatever device you're trying to bring into the hub. So if I have temperature sensor, blood monitor sensor, whatever device it is, camera, let's say CCTV camera, all various devices, refrigerator, they all represent devices, and I must create a device, virtual device for each one, collect this connection string for that particular device, and use it on the model, or on the model of the external device I'm trying to connect. So right now I have my hub ready, and I'm going to go through the menu to devices. This will allow me create a virtual device on my hub. Okay, right now I only have one device there, but I'll still show you the procedure for creating this so that it can be made easier. Find the device. There's an existing device in this hub, but the procedure is that I click on add device, give the device ID of whatever device. Let's say it's a refrigerator. I'll type refrigerator. Let's say that's the third one in my house. I'll name it. So every smart device you have has to have a unique name. If it's refrigerator 1, refrigerator 2, you have to give them maybe refrigerator from Hensen, from whatever the company is. You just name your devices. Smart TV from this, just give them names so that those names will be their identifier when it comes to bringing them to the cloud. So this, I cannot just use the name refrigerator. I can call it refrigerator 3, 2, and so on. Then having done that, I will save. But again, I don't intend to save. I have a device that I intend to use. In this case now, my device is a Raspberry Pi temperature sensor, BME 280. So I already created that. This is just the procedure for creating it, creating a new device. And if you do that, it's enabled already, you save it. So again, sorry, I'll go back to my hub and collect the device I have already. This is the Raspberry Pi. I'll open it. So assuming I've created one, it will simply deploy it and still bring me to this point. Okay. Now, this point is very important as it has to do with collecting my connection string. The connection string gives you the key to connect your external device. I already said that. So I'm going to minimize this and collect the primary connection screen. I don't know if you can see that it is encrypted, so I can view it and then just click on the copy icon. Then I've collected the connection string. Next thing, I'm using a virtual device. So I'll open my virtual device and link this device to my hub. Right now, looking at the code in the device, line 1, line 2, line 3, up to line 15. On line 15, I'll be having const connection string. And that's exactly what I've copied. So I'm going to highlight immediately after the quotes. I'm going to highlight everything inside the existing, keep taking it to the end, highlight all, and then paste the connection string I just copied from my virtual device. Okay. I've highlighted, Control V. I've pasted the connection string. Okay, with that, I can now send telemetry from this simulated device and see if it will be received. But before that, we need to create storage, we need to do other things. So, but let me just start running the system so that whenever we are done, we'll now view and see if it's being received. Okay, I'm sending data already. I'm sending, it's supposed to be received. So, but let's create our storage. From the storage, you can now view to know if it is being received. The next thing to do is to, right now I'm sending telemetry from a device. Next thing to do is to try and process whatever is being received. So to process that, there is an application here, a resource that is called stream analysis. Stream analytics is a stream processing resource that allows you to process whatever stream of data that you receive in real time with little code. That's the beauty of AI. In fact, there's high abstraction from what you should be doing and doing all the coding yourself. Most codes have been actually carried out and you just do little coding. So I am going to also show how this can be done. I'll look for the resource on, I'll type in stream analytics. Now the stream analytics comes in two variants. We have the clusters and the jobs. The clusters are for critical cases, critical scenarios where you have, let's say, maybe life-threatening scenarios like heart monitoring devices and so on. So they are quite expensive to keep. So we are, for this demonstration, we're going to be using stream analytics jobs. Okay, I'll still show how to create this. I have one already. To create one, click on the create button. Yeah, the job name is a unique name. You can call it, right now I'm carrying out an analysis, so I'll call it, sorry, small letter O, analytic job. Okay, I call it an analytic job. I like to append the name job to know that I'm using stream analytic job. So if it's process, I can call it process dash job, whatever. I just like to use the name job. And whenever I see job on my list, I know that this is a stream analytic environment. Okay, so you already have Azure subscription one. Like I said, every resource must come under a subscription. And then I'm supposed to choose a resource group. Remember, we've been using the analytic resource group. The location has been brought in already. I'm using South Africa. Now, for hosting environment, this is important. I'm using the cloud, but the edge hosting environment is also very important because that allows you to host both the analysis and the processing on device. That's why we call it on edge. So this is used for critical cases also, let's say in pipeline monitoring, water gauge monitoring, manufacturing line monitoring. You can have your devices hosted at the various points and then use the edge cloud, the edge system hosting environment, which allows analysis. Data will be sent to the cloud quite all right, but not all that, only important data, critical data. But analysis is carried out right there on the device. So, but for this demonstration, we are going to continue with the cloud hosting environment. Scroll down. By default, we are assigned 3 units, but we are going to make it 1 unit because we are not doing much. So click on create. But right now, of course, I'm still not going to click on the create because I have one already. I have created one already. So I'm going to pick the one I have. Okay, this is my analytic job. So I'm opening it. Now, in this environment, there are 3 key points. The first point is everything is under topology, job topology. I hope you can see that here. Under job topology, we have the inputs, the functions, the query, and the outputs. And with these 4 items, everything can be carried out. The input has to do with where is this data coming in from? You have to select the source of data. Then the query has to do with using SQL query language that has been a kind of template has been provisioned. And then with that, you can query the data, the content that you received. Let's say I'm trying to monitor my blood sugar and I give a threshold of if it exceeds 70, let there be a trigger, a monitor, an alert. So let's say I'm monitoring temperature as we are doing right now. I give a threshold. Once the temperature exceeds so threshold, please notify that, okay, collect temperature only for the ones that exceed a particular threshold. That's what the query does for you. So with this query, you can actually do the main analysis. So what we have is inputs, query is done, used for analysis, then the output, whatever has been processed has to be stored somewhere for further insights, or you can look at it later, forward it or for another processing, machine learning processing, and so on. Now, in this environment also, okay, let me just go ahead. Let's look at the inputs. Okay, to create an input, of course, you have an input that created already, and this is coming from IoT data. The important thing about creating an input is that you should name everything IoT hub. Don't forget your devices are connected to an IoT hub. So whatever input you're receiving basically comes from your IoT hub. So assuming I didn't have one, I'll click the add button and create an input. Okay. So, but I have created an IoT hub, which I've shown that severally how to create a new item. So right here, I have my IoT hub as my source of data. Okay, having that already, I'm going to go straight to query. Yeah, in the query environment, it gives you SQL sets of what to use. So in this particular SQL query, I'm using temperature. So what I do, like the templates you will see or receive when you're starting first time, will just be the select, into, and from. So I have here the IoT hub as my selects. Then I'm looking at into as where I should drive this to. That's a storage. We are going to show how this storage account is created. And then the select, what am I working on? What are we looking at? I'm looking at temperature from a particular device, okay? Let's test this query. No data, let's go back. Okay.
First, we request you to have a watch on the time.
Okay.
Yeah.
So all I'll need to do
Thank you.
is refresh this. Yeah. At this point, I should be receiving my message from the sorry. Okay. So actually, this is the procedure for having your query, and I'm supposed to have, okay, I have one function inputs. I have the IoT hub, and then my query is loading again.
Sir, I have a doubt, sir.
Okay, so I think this is the procedure. For want of time, I needed to have created a new one and test run this. So, but because of want of time, I'll simply go back to my PowerPoint and finish up.
Sir, I have a doubt.
Yes. Okay, so
Sir, what?
I've demonstrated how it's done.
We request the participants to wait until the presentation is
And
over.
the functions can be created. Sorry, yeah. Hello, can you see my slide?
Yes, yes, doctor, we can see.
Okay. All right, so if I'll finish that, telemetry will be received, and because I didn't create new input output, but that's the procedure for carrying out the functions. So, and in the area of conversational AI, I can have my, sorry, let me open my screen. I can speak to my phone, allow the phone to collect telemetry, okay, from an environment through an app called Alexa, okay? The Alexa allows me.
Participants are requested to be on mute while the presentation is on. Sorry, doctor.
I can actually activate my device from my cell phone. The cell phone app called Alexa is an Amazon app that allows you to, you can use it to speak to your devices, you can use it to speak to connected devices, or so long as they have the device connected to the app. So this app simply leverages conversational AI and allows you to speak to devices. So I can actually connect my temperature device to this app and ask it to start monitoring the temperature, ask it to start taking telemetry, and then forwarding telemetry. If the app has the, if the device has the input string or the connection string from my app, it will simply start carrying out the function and send the telemetry. Okay, sorry. Please, I'll still want to finish with this.
Yes.
Permit me to open this job. Okay, but if we don't have time, I can actually allow this seat. Okay. All right, thank you. So this is the procedure for connecting your device, having telemetry sent to the cloud, and viewing it in the cloud. We can create all these, have functions created in the environment, and have storage accounts that can view them. So maybe I should just go through what I have already for want of time. Let me open my storage accounts. Storage accounts. This is the stream data analysis. And the container has been created in here. Now, inside the container, I have contents. Yeah, a stream. These are my streams data, which I can actually view from the instructions given initially. So the content of this can be downloaded, and then you view whatever telemetry has been sent from the cloud. I can open this, and it opens up in Microsoft Azure. Okay.
Doctor,
Yeah, just a
I
minute.
need to remind you a bit of the time, sorry.
Okay, 1 minute.
Yeah.
Yeah.
Participants
So
are
see what
requested to
I
be
have
on mute.
received so far. See what I've received so far. I have the temperature as 20, 31, and so on. These are the temperature received. And I actually gave instruction that if the temperature is above a particular threshold, please return false, return true. Else, let the output be false. So in this case now, I have whenever it is above 26, that's what I set it, and it will return true. And if it is below that, it will return false. Thank you.
Thank you, Doctor. Thank you for that extensive session and the practical presentation live for us. We had to interrupt you a couple of times because of, we were running behind our schedule. So we would definitely we are sure that we'll have a separate session for an in-depth understanding on this. So we have Ms. Priya RL back. She had a few network issues and she's back on the session now. So Ms. Priya RL would be covering on the topic script recognition using NLP. Ma'am, please, it's over to you.
Dr. Comfort should
have a joint.
Thank you, Priya.
We'll have a joint question session after this for the last two sessions, definitely. Yes.
Dr. Comfort, please unshare yourself.
Thank you, sir.
Dr. Comfort, you have to unshare, please.
Can you?
Okay. Priya, can you try sharing? Yeah.
Yes, sir. I'll try. No, it says that you cannot share the screen while other participants.
Yeah. Let me text her.
We request the participants to be on mute while the presentations are on. We do keep hearing some background music, so that the presentations are not disturbed. Please recheck if all of you are on mute before we start with the next presentation. And you can have stock of the questions that you had with for Dr. Comfort's session, so that we'll be having it addressed after Ms. Priya's session.
I think Dr. Comfort has come. She'll unshare.
Okay.
Priya, can you do one thing? You
Yes.
enter share screen, and this will
Okay.
stop other screen sharing too. Do you want to continue? Say yes and you.
Hello.
Yeah, please remove Dr. Comfort.
You cannot start. Okay.
Yeah, good.
Yes, sir, it's sir.
She's good.
Hello.
Yeah. Visible?
Yeah, it is. It is, Miss Priya. We can see it.
Hello.
Yeah.
Am I audible to you all?
Yeah, now you're clear. A little bit, it was unclear a little while back.
Hello.
Yeah, we can hear you, Miss Priya. I hope others can
Am
hear.
I audible?
Your voice is clipping, Miss Priya. I'm not sure about the others. To me, it is clipping.
I'm not hearing her properly.
Okay. Even I had an issue. It was clipping actually. Miss Priya, can you hear us? Okay.
Where did Miss Priya go?
Yeah,
She'll be
hello.
back. She'll be back. Yeah.
Okay.
Yeah. Is my screen is visible now?
Yes, we can see
It's
it now.
up. We could see it.
Thank you.
Thank you.
Good afternoon, one and all. So directly let me get into my session. This is about script recognition using NLP. So before we get into the details of script recognition, let me first explain you about what is NLP. So that is it, natural language processing. So today our agenda is, I'll be covering the basic introduction and the overview of NLP and script recognition, that is using optical character recognition or the OCR method, and how this has been implemented for one of the Indian language, the oldest Indian language, that is Gujarati. And what are the data set details along with the implementation details, and what are the various techniques or the methodologies that was applied for the Gujarati script recognition using natural language processing. So what do you mean by natural language processing? When I say natural language, it can be any language, what we use to communicate with each other. The humans usually, either we speak in our mother tongue or any means of a language, English, German, French, or any Indian regional languages. So why we need to process it? Now, if I have to communicate between the machines, that is machine and the human being, then whatever the natural language which the human user convey it to the machine or the computer system, that should be able to process it, understand first, process it, and then it should be able to generate the response back to the human user. So we can say that NLP, it's a part of artificial intelligence or the computer science field. And this is mainly meant to design. As we all know that in our day-to-day life, we are using n number of NLP applications. Chatbot is there, Siri is there. There are many NLP applications that we are using it. So this is mostly concerned with how we can interact.
Please continue, Priya.
Yeah.
It's glitching.
It's glitching.
Please continue. It is glitching, I believe. Let us know.
Ma'am,
Ma'am.
Please continue,
for
madam.
Srimati, ma'am. Justice for Srimati, ma'am.
Can please go on mute?
Mute it. Mute the music. Thank you.
Our teacher will be back shortly. She just messaged me. She's having some difficulties, for anyone who's wondering. She had some difficulties with her electronic.
Hello.
So.
Thank you. So in any NLP application, if you give the input in the form of image or in the form of audio or text, it should go through certain process. So in any natural language, we need to recognize the parts of speech, that is nothing but the grammar of a particular sentence, and the structure of the sentence which need to be processed, that is parsing a sentence. And then we need to recognize the named entities. So in a given paragraph, say for example, the person name, the organization name, and the date, when he has joined that particular organization. So there are certain things that the named entities which need to be recognized as, and once the characters or the textual information is retrieved.
You asked me. You asked me
which
to
can be applied into the ML model. Sorry.
You asked me to unmute.
Hello.
Hello.
Don't worry, please keep going.
Okay, sorry.
Okay. So finally, we can apply the efficient ML algorithms or any kind of techniques. Either it can be knowledge-based algorithms or the dictionary-based methods, which can be applied for the NLP, that is for the classification of testing. And how this NLP processing that will be done in the 5 different stages. So only in the case of the voice input, we need to analyze or we have to process the phonetics, that is a phonological layer. And if the input is in the form of text or the document, we have this 5 different stages, which is the morphological layer, syntactic layer, semantic layer, pragmatic layer, and the discourse layer. So in the case of this morphological layer, we need to take care about the word formations and its related grammar. And in the syntactic layer, that is in the second layer of the text document processing, we need to mainly concerned with the structure of the sentences. And in the next layer, it will be trying to find out the correct meaning of each and every word that is present in the sentences.
Dr. Christman.
Followed by, we have the pragmatics and the discourse layer. That is, according to the given context, is the syntactic and the semantic structure is appropriate or not. So these are the various levels that we will do it in the any NLP applications. Now, as a final frontier with respect to any natural language, there are 3 important things which we need to always remember. That is NLU, which is a natural language understanding. So if I need to generate a response, that means I need to have the combination of natural language understanding as well as the natural language processing. That is NLU and NLP. So NLU is, let us consider we are taking some spoken or some typed sentences. And that should be worked out to understand or interpret the meaning of the spoken sentences or the text sentences. And with this, the natural language generation, what it does is once it interprets the meaning or the syntactic, the structure, everything should be processed, and finally it should be able to generate the response back to the end user. So any natural language processing application will have 3 important phases, that is understanding, generation, and NLP. So one of the important applications, though we have multiple applications in NLP, one of the important applications, that is the translations, machine translations. So we are very familiar with the Google Translator. The similar concept, when I give a sentence in a particular language, natural language, that needs to be converted into the destination language. Say, for example, from English to Hindi or Hindi to English or any other foreign languages as well. So the same concept which we are going to do it in the script recognition. So what is the difference over here is now we are giving the input as an image. Some picture is provided to the NLP system and the text that is present in an image that should be recognized. So we can say OCR or the optical character recognition method. It is a method of recognizing and interpreting the text that is present in the photos or the images in a digital format. So it has been
Who is that ugly motherfucker?
In order to retrieve the historical documents. Those are the things, maybe the text that we need to extract it from the newspaper clips, the old newspaper clips, or from even for sorting the mails and for certain other applications also, we can use this OCR technique. So the beauty in this OCR technique is we can do it in a more accurate manner using various AI techniques by checking out the errors and etc. According to this,
please mute.
By using the OCR technique, we have proposed a Gujarati script recognition system using this NLP technique. So why we have chosen the Gujarati languages, though it is one of the oldest Indian language, it is also adapted from the Devanagari script. And it consists of almost 34 consonants and 13 vowels in this particular language. And according to our survey, what it was being observed is the character or the word identification, recognition for the English language, it has been well developed as of in the present situation. But the Indian languages, especially say, for example, Gujarati, so which was in a development stage. So most of the difficulty over here is in Gujarati, we have seen that they don't have any distinguishing line on the top of the word. So in Hindi, actually, we have the line which able to distinguish between the characters or the words, which is not present in the case of the Gujarati. And the other observation, what we found is character recognition performs better in the case of the Gujarati compared to word and the sentence recognition. So though they have applied multiple deep learning traditional machine learning models, but it was not up to the mark. So we have taken that as a challenge and we worked this particular problem statement with partnership to Tata Institute of Fundamental Research, that is TFR in Mumbai. So with the expert guidance, so we have developed this particular project that is a script recognition using the NLP technique. So the entire flow of this particular model, what we have used is any input image is given. That means certain pre-processing that is required. Why we need to pre-process the model? Because there are noises, right? And with respect to resolution or maybe with respect to the clarity and so on. So the various pre-processing techniques such as resizing the image, that is basically scaling the image. So that was implemented. Followed by, we have also tried to enhance the image so that we can improve the quality of the characters. Along with that, we have also used the skew corrections in order to improve the contrast as well as the brightness of the image. So there are certain pre-processing technique was used, and even followed by this, we have also applied the binary thing, that is using the counter detection so that we can detect the borders of the image, that is especially the lines and the columns of the image. So after applying this, then this is also been said, that is before we train the model, we need to do certain important steps, that is the line segmentation, word segmentation, and the character segmentation. So what do you mean by the line segmentation? That is, we need to separate the different lines of a text that is present in the given image. So we have used in the line segmentation, that is a horizontal historical methods. So I'll just show you that. Yeah. So that is the technique that we use is a horizontal histogram projection method. When you say histogram, that it is a graph of pixels of values that we can extract it from a given image. So here the number of pixels along the rows are counted. So what will be the output of this particular segmentation, that is line segmentation, is the array size, which is nothing but equal to the height of that particular image. That means number of rows. And when you plot it in the graph, as a graph, when you observe it, it will be the x-axis, which will be representing the number of pixels, and the y-axis, which will be representing the number of rows. So the graph which will have the higher peaks as well as the lower peaks. The higher peaks that will be always indicating separating the lines, separating the different lines. And the lower peaks which will describe the gaps between these two lines. So this is an input image which is fed into the system. And after applying the horizontal histogram projection method, that is in the line segmentation technique, so we'll get the output that is separating the lines. So you can find out the set of sentences, the words that is in the first line, second line, and so on, and the gaps between these two lines, which has been segmented or the separated in the case after applying the line segmentation. So once the line is segmented, then we need to do the word segmentation. So in the given line, we need to now separate the individual words. And then followed by, we have to apply the character segmentation. So in the word segmentations, we'll be applying the vertical histogram method. So here it will be like the x-axis, which will be representing the number of columns, and the y-axis, which will be representing the number of pixels. So it will divide each and every individual words from the given sentence. Similar concept, then again, we are feeding it into the character segmentation. So where the characters are segmented or it has been extracted from the image, and then it will be fed into the classification model. And we try to apply the annotation technique in order to improve the better data set. So that has been added in the classification model.
Excuse me.
Yeah.
What is the technician technique?
Pardon?
What is the annotation technique?
Now, please ask in the last, not now. Please don't disturb in the middle.
Oh, I'm sorry, my bad. Continue.
Continue.
Yeah, I'll explain at the end of the session, definitely.
Continue, I'm sorry.
Thank you. So followed by this, then we also implement two more extra features. One is spell checking, as we have it in the normal Microsoft Word documents. Here also you can do the spell check, and if you feel that, you can suggest with this new label, new characters, then that can be replaced over there. And the most important feature that we have applied in this system, which is about the article search, because we need to find out that, say for example, a keyword is given, okay? So in what all newspapers, those keyword that appears with the date of published newspaper. So we have taken multiple images of the newspapers, Gujarati newspapers, and which was fed it into the data set. Here we'll be having multiple that is parameters. One is with respect to keywords, another one is the name of the newspaper, and the next thing is date of publication. And when you are doing the search, we also provided that what should be the starting date of the newspaper and from which date. So if you want to define any duration, start publication date
Dr.
and the
Kirshner?
end of publication date. So these things can be provided as for the article search. So I would like to explain about what's the data set that we have used. Though we have got a very little input from the open source, we also, especially for the joint characters, because in Devanagari script, there are multiple combination of characters and matras. So for each and every class, around 615 classes that we have designed, including the numbers, characters, joint characters, punctuations, everything. So among the 615 classes, for every class, we see to it that minimum 130 to 150 images was fed into the data set. And this is what I explained for the data pre-processing, that is from the segmented characters. We try to improve the quality of each and every character during the pre-processing. That is resizing the image as well as, this is just resizing. This is after applying the enhancing as well as the resizing of the image. And the output of this model, it's not exactly into the Gujarati text. So I'll explain you in the technique, that is we have used deep learning network models, that is CNN as well as efficient net model. So the output of this, that is at the output layer, that is a softmax function, which will give the output, which is the multi-class label, which gives it in the probability scenario. And it will be in the form of, say, for example, if it is star, so it will be T and A. And then it will be converted into the form of Gujarati text. So this is the mapping that has been defined in the dictionary of the model. So the segmentation details, that is in the line segmentation, that is we have applied the horizontal histogram projection method. So the image which can be segmented line-wise, followed by the word segmentation. So after applying the vertical histogram method, so each and every line which can be separated or divided into its individual words, and then followed by the character recognition, each and every characters, okay, either the individual characters or the joint characters which has been identified. So we have created our own data set, especially for the joint characters and for a few other characters as well. And the annotation, that is before we apply it into the training model, we also use the annotation, that is basically to give an extra explanation to an image. So that helps us to increase the almost 90,000 words were collected. And each and every word that was stored as in a new line. So in a single line, only one word that was stored over here. And that is stored in a text file. And later on, what we did is the text file, which was converted into a PDF file, and then we took the image of that. So that is how we made it. We just enlarged the data set for our system. So this is the screenshot for the annotations, that you can select an image or any photos, newspaper clip as an input image. And then the annotations, that is a set of labels, which will be appeared as a pop-up box. You can choose the respective things, and whichever you would like to add or delete or want to perform any kind of operations, which can be performed and added into the existing data set. And the most important section that is in the script recognition is training. So the training, which we can apply any kind of ML algorithms. So based on our survey, we found out, compared to the statistical machine learning models, the deep learning neural network model will work better, perform better. So that's the reason we have started applying. We have chosen two different models. One is the CNN model. So hope you all are familiar with this convolution neural network model, which is a multi-layered. So it's like you consider each and everything as a layered model. So it is a multi-layered, and it is a feed-forward neural network model. It is mainly designed with, so in our case, that it's almost 20 to 30 layers was used by stacking the multiple hidden layers on top of the each other in sequence, so that the CNN can easily learn the hierarchical features. So followed by the convolution layer, we also have the activation layer, that is ReLU, or the pooling layer. And in the final output layer, we can see the softmax. So these are the various activation functions, depends on the problem statement and this thing, it may vary. And when you consider the pooling layer, it can be of either two types. Either you can have the maximum max pooling layer, or you can have the average pooling layer. So this convolution layer, that is basically three scaling dimensions are used in the CNN model. One is the depth, and the second one, which is about the width and the resolution. The depth is nothing but how many number of layers that is present in your network model, and the bit will be your size of the network, and the resolution that is actually the image resolution. So what I can do is, as I use or stack more and more convolution layer, I can increase the depth of the CNN network so that it will help you to learn more and more complex features from the input image. And the second thing is, if I have to increase the width of the network model, so which will help as you increase the network model, which will help you to learn more and more grain features. So that is the basic thing, and the detailed information which you can retrieve it when you increase the resolution of this. So these are the basically 3 scaling dimensions which we apply it, or you can tune it accordingly. And there are certain tuning parameters like momentum factors are there. So that also you can design. So in this case, we have considered the momentum factors at 0.90 because to get a better results. So I'm not going much into detail. And the next, another version of the deep neural network model that we used, which is an efficient net model. It uses the mobile inverted Bottler convolution network, which we call it. It is of version 2. And here, in this case, we have added this as a base model. And in addition to this, even the optimization technique, which has been used, that is a skews and excitation optimization technique, which has been used to improve the accuracy of this. And then we compared both the models with the testing objects. So here we have found that the accuracy of this CNN model is 89%, and whereas the efficient net model, which is around 97%, and we have also calculated almost 10 epochs that we have used for this efficient model. It took almost 3 hours for this class to complete the processing time. And the inference time, that is the testing time that is used for the CNN, that is with respect to CPU, it is 8 seconds and this is 13 seconds. And with GPU, it is 2.4 and 4.6. The model size, which is bigger compared to the CNN model, and the number of layers, it's more complex so that we can get the more better results. So we decided that this is the best model in the case of the Gujarati script recognition. And the last 2 important features which we added into this model, which is the spell checker, and another thing is about the article search. The spell checker is if you want to check the spelling. So for that, we have used the dictionary or the library, that is a Huntsville dictionary. And Encant is a kind of a library and the user interface, which will help you to perform many other operations. Like if you find that a new word has been identified, then that can be inserted or it can be replaced. Or if you want to remove, so certain operations that can be performed by this Encant libraries as well. So this is a basic coding that we have used for the spell checker, and it will come up with the, so as I give the input text as an image, then it for this particular language, and we can consider that. And the last option, which is about the article search, that is, I can search for a particular keyword in the old newspapers. So what we did is we have scanned multiple newspaper images, and that has been converted into the text by applying the OCR technique, and that has been stored in the data set. So with that, we have it helps us to perform the article search based on the keyword and the name of the newspaper as well as the publication date. So when I give this thing based on certain keywords and this thing, so it will give you in which newspaper and the date that it has been published. So I can give you the keyword that to be searched and what is the newspaper, say for example, Times of India, and whatever the starting date, from which date to which date newspaper which you would like to search it on. So based on that, you can get this. So in the OCR techniques, even we can use YOLO View4 technique also, but due to certain limitations, we couldn't proceed with that implementations. But compared to CNN and the efficient net model, we found this was the best model for the Gujarati script recognition using the NLP. So thank you.
Thank you, ma'am. Thank you for that extensive presentation on script recognition. May I request the participants to make use of this time to address any questions to Ms. Priya and also Dr. Comfort. You could, we have a couple of minutes for the question and answer session, for the last two sessions, in fact. If you have any connectivity issue, you could also make use of the chat so that we'll be in a position to share the questions to the speakers. Okay.
Thank you, team.
Thank you. Thank you, ma'am. Thank you so much.
Thank you, Priya. Thank you, Krishna, sir.
Yeah. Okay. So we move on to our final speaker for the day. We have Ms. Abirami. Hello, Ms. Abirami. I hope you're able to connect. And yes, we already see you. Okay. Yeah. So welcome to the forum. We have Ms. Abirami as our final expert speaker for the day to share her knowledge on the topic, artificial intelligence for cybersecurity. To quickly have an introduction on Abirami, Ms. Abirami has a master's in engineering specializing in information technology. She's currently pursuing a PhD specializing again in information technology. She has over 16 years of teaching experience, and Ms. Abirami is currently associated as assistant professor in the IT department of Bannari Amman Institute of Technology at Erode, Tamil Nadu, India. Her contributions as part of the editorial board of research and reviews are many. I'm just restricting myself, keeping in mind the time limitations we have. The few that I want to mention were Journal of Internet and Networking, Recent Innovations in Wireless Network Security, Research and Applications of Web Development and Design. I have only named a few, in fact. She has many more. She has participated in many seminars and has also been organizing many workshops. She has more than 30 publications in journals, conferences, books, and chapters. Ms. Abirami's area of interest are computer networks, cybersecurity, and digital forensics. Welcome you, ma'am. Please, the stage is all yours.
Thank you for your nice introduction.
Most welcome.
Let me share my screen. Yeah.
Yes.
Hope it's visible, right?
Yes, we can see, ma'am.
Very good evening from India to all the participants and Krishna sir and the team of World Resource webinar. Yeah, the topic I have taken here is AI in cybersecurity. So let me get inside the topic. Yeah, so these are the contents I'm going to take today, like AI introduction, what's cybersecurity and why AI has been needed in cybersecurity, what is threat landscape and the various types of cyber attacks that has been there, and how AI ML is going to help in adaptive access and how it has been going to utilize in vulnerable detection and the various applications of cybersecurity too. So first, we'll see about what is artificial intelligence. Yeah, so from the name itself, everyone can guess like what artificial intelligence is about. So artificially, we are going to provide some intelligence to the system or to the machine, and the machine is going to take this particular intelligence and it's going to act like a human being without any intervention of the human. The machine is going to act like a human. So that is what has been expected in artificial intelligence. And what, yeah, ma'am.
Yeah, we request you to have us in the presentation mode so that we'll keep having a view of your slide. We are just,
One second.
Thank you, ma'am. Your slide was visible to us. Only thing was the presentation.
It's not moving.
Yeah, it was not moving.
Okay.
I'm sorry, I had to interrupt you.
No problem. Is that now?
Yes, we can.
Yeah, but it's not moving from my end, I guess.
Okay.
Yeah, now it's moving.
Yes, yes, we can.
Okay,
We
okay.
can see it.
Yeah, thank you, Priya.
Thank you.
Yeah. So what cybersecurity is about? Nowadays, it's a digital era. Like everyone are having the smartphones, everyone are using laptops, everyone are using internet. So n number of applications everyone are using over here, and everyone are transmitting the data. So of course, we need to secure all the data that has been there in the digital era. That is what cybersecurity is about. So cyber world, we need to secure the content that has been transmitted in the cyber world that has been expected in cybersecurity as such. So for the hackers, as even after pandemic situation, it will become very easier for the hacker to launch any type of attack, as n number of activities we are handling in the digital world. For example, major of the bank transaction, we are doing it over here in the digital world. And even in the schools, colleges, all the activities, whatever we are carrying out, we all are doing by transmitting the digital content over there. So it become very easier for the hacker to launch any type of attack in this particular digital world. So how this particular AI is going to stop all those activities, that is what we are going to see today. So we need to understand what this threat landscape is. When a particular hacker is going to launch any type of attack, what is lagging from our end is that our system is not so secured. So there is some vulnerabilities that has been available with the system. So that is what the lack now we are providing to the hacker to easily keep track of us and our systems, the networks, and he can easily launch the attack. So that is what the threat landscape is about. Like it is a vulnerable environment we are providing to the hacker to easily launch the any type of attack he is wish to carry forward over here. And these are some of the major attacks that has been happening often in the digital world. The first one is malware, second is phishing, third is password attack, third and the fourth one is a distributed denial of service attack. So we'll see one by one what's this is. So the first one is malware. So malware, from the name itself, you can guess it like it is a malicious software that has been injected inside our system. So we have some set of categories of malwares that has been here. First one is the computer virus. In a human body, when the virus has been entering into the system, yeah, of course, our system is going to, or our body is going to react for that. Same way, when some set of files or some executable file has been injected inside our computer system will get infected, and it is going to react, or it is going to spoil our system, or it is going to corrupt some of the files that has been there with the user. So that is what the computer virus is about. And the next one is spyware. Spyware, it is nothing but it is something that has been spying our system. So what this attacker will do is that without the user knowledge, he'll inject something inside our system. And what this particular spyware will do here is that it is going to spy the user activity and how he can able to collect some valid information from the user and use it for his own benefit. So that is what spyware is about. So it will be silently monitoring the user without the knowledge, like it will be collecting our information and providing to the hacker. So that is what will happen with the spyware. Adware, many would have seen also, like whenever we are using the cell phone or in the laptop, whenever we are using some of the browsers, some of the pop-ups will come out. And what the user will do here is that we'll click on that particular pop-outs, and without our knowledge, something is entering our system and spoiling our system. So that is what adware is about. So with the help of the advertisement or advertisement pop-outs, our system is being getting injected by some of the unwanted malicious content, and our system is getting corrupted. So that is what adware is about. And the worms, that is nothing but it is similar to that of the virus, and it's going to infect the system. It is not going to spoil our own system. It will continuously try to spread on to some of the systems also. So these are some of the malwares that has been available. And Trojan horse is nothing but it looked like a legitimate software, but actually it's not a legitimate software over here. What this particular software will do is it will silently be there in our system, and it's not going to react for anything, but it will open the door for the hacker to inject any type of virus, any type of attack, that it will act as a backdoor in short. So it is going to provide the way for the other type of attack to get inside a system. So that is what the Trojan horse is about. So it's not a legitimate software. It will act as a legitimate software and is going to infect our system. So that is what malware is about, and how this particular malwares are getting inside our system. So the first one is email attachment. So normally what the user will do here is that whenever we receive some mail, we are not going to think much of it. We'll just like that click on the links that has been provided in the mails. We'll download the contents that has been available in the mails, and through the downloads, through the attachments, through the links that has been provided, malware has been, or the viruses has been getting inside our system. So the next one is the software downloads. So normally the user, or what we used to do here is that when we want to download or when we need some application, there will be n number of websites will be available. So we won't go for the legitimate websites. Instead of that, we'll go for some shortcuts, and we'll go ahead with some free softwares that has been available, and we'll download it from unauthorized websites. So through unauthorized websites, these types of malwares will be injected. So we should be very much serious about this particular thing. Like when we are downloading the things, we should understand is that we are downloading from a legitimate website or from unauthorized website. So we should be very careful. And the next one is OS vulnerabilities. So of course, we might be using different set of operating systems, and we should understand how vulnerable our operating system is. If our operating system is so vulnerable, of course, it will become very easier for the malware to get inside our system. So it should be secured, of course. So we can stop this particular malware is that whenever we are getting any links through the mails or whatever it might be, we should be very much conscious about that, and we should not click on any of the links that has been provided in that. And update the firewall. What this firewall is about? So basically, when we talk about the firewall will be a wall between our system and the external resources that has been getting inside our system. So how we can block the external resources to get inside the system is that with the help of this particular firewall. So normally what we are supposed to do here is that we are supposed to update this particular firewall frequently, so that the current type of attacks will be understood, or we can able to block that particular malicious content, and we can stop this particular malicious content to enter inside our system. And of course, there's very much necessary to update our operating system also. So the next type of attack is the phishing attack. So what this phishing attack is going to do here is that it's going to collect the financial content or the personal data of any type of user. So normally what this particular attacker will do is that he'll send some broadcast information, and it will reach all type of users, and whoever has been clicking or whoever has been receiving that particular information. So through that particular person, the hacker is going to collect the personal data or the information that has been necessary for him for his own purpose. So what this phishing is being used for is that, so how the hacker is going to get benefited using this particular phishing attack is that he might be stealing the confidential data. Suppose, for example, if you're working in an office and the employee data has been there, so through this particular phishing attack, he can able to collect the confidential data of the employee, his salary details, his password, whatever content that has been necessary. So based on that, he can able to launch the type of attack. He can collect the information as such. And the confidential information can be taken from a particular person. And impersonating the content means, suppose, for example, I want to communicate with B, but a hacker can act as a B, and he can convince you, and easily he can able to collect the information. So this is how the phishing will be utilized. And see here, this is one of the example has been provided over here. So when we see this particular mail, we'll think, yeah, it is coming from Amazon.com. Yes, as the logo has been provided over here, and the Amazon, the mail ID has been provided over here. But when we check the entire mail ID of the Amazon, See here, the A is missing over here. So when we see this particular, so when a mail has been coming, and if it has been Amazon.com, they'll provide some set of offers. So when the user is going to see such type of mails, what our user will do is that automatically click on, yeah, it is 50% offer. Yeah, I can click this particular link and able to collect the offer info. So here, but in real, it is not the Amazon mail that has been received over here. So the user should be very much conscious about this. And when the user has been provided with, yeah, click on the link over here, what the user will do is that normally we used to click on the link and it might take you to some of the other websites. So make sure that when it is at least going to the other websites, you check the URL of that particular website to get out of this particular type of attack. And the next main type of attack over here is the password attack. So yeah, of course, password means like how the hacker is going to take your password for his own benefit and to get the access of any type of systems that has been provided over there. So there are three types of password attacks has been available. One is the brute force attack. The second one is dictionary attack, and next one is the keylogger attack. So brute force attack. So brute force attack, how this particular hacker is going to launch over here is that he'll try with some combination, like suppose, for example, if I know a user and the name is Abirami, suppose, for example, how I'll make a password is that, yeah, my name might be there, or some half of my name might be there, and my birth date might be concatenated with my name, or as my mobile number might be concatenated with the name to create the password. So it become very easier for the hacker to make some combinations of the username, and he can easily track of your password. And the next one is the dictionary attack. See, normal common users will be having this particular way of providing a particular password. See, like admin, the password made me admin. The username is password, and or username is something, and your password will be the password itself. Or some common words from the dictionary might be available with the as a password. So what this hacker will do is that he'll have some set of words in a database. He'll try with all the set of data he is having, and he'll check with the availability, or he'll cross check with the password that has been matching. And if yeah, of course, if it is a common word, of course, it is very easier for him to take the password as such. So the next one is keylogger. So keylogger means like what the hacker will do here is that he'll inject some of the software inside our system, and that is nothing but a keylogger package. So what this keylogger will do here is that whenever a user is going to use the system, when he presses a particular key, the keystroke has been collected by this particular software, and it will be provided to the hacker. So it will become very easier for whenever I'm clicking a particular password, or whenever I'm entering, whatever I'm typing in my keyboard will be collected by this particular keylogger and will be provided to the hacker. It will become very easier for him to predict the password. So how we can able to stop this type of attack over here is that, of course, we should frequently update the password. See, when a neighbor has been sitting next to me, if I'm frequently going to utilize the same password, it'll become very easier for him to understand our password, right? So it is our responsibility to frequently update our password. And when we are using a particular password, we should have some combination of alphanumeric combination should be there. So it'll become very difficult for the hacker to keep track of our password. And don't use any simple words that has been available in the dictionary as our password. So in this way, we can able to come out of this particular attack. So the next one is a denial of service attack. So there are two types. One is distributor denial of service attack, and other one is denial of service attack. Denial of service. So somehow we are going to deny the service to some of the clients or the legitimate clients by making the server busy with the unwanted data boosting from the botnets. Botnets are nothing but the infected systems or the system who is going to launch this particular attack. So suppose consider this as a server who is going to provide services to some of the clients, And these are the attacker machines. And from this particular machines, if flooding of packets has been happening, or the flooding of data has been happening, flooding of fake requests has been provided to this particular server, what this particular server will do, basically it will become busy with this particular packets that has been launched from the hacker machine, and the service for the normal client will be denied because of this particular activity. So so this should not happen. So how we can able to prevent these type of denial of service attack over here is that we are supposed to analyze the network traffic that has been entering our system. So analyzing the traffic means, like at this particular time period, the traffic is very high, and this particular time period, the traffic is very low. See, normally the user will be accessing or purchasing an order at a particular time period. So what this particular hacker will do is that he will set or he'll flood the unwanted packets to this particular server, so that the server will become busy with these particular packets, and he could not able to provide any services to the normal client. So we are supposed to analyze the traffic, and the traffic should be controlled, or if we can understand, yeah, from a particular node only, n number of packets have been coming over there, so we can able to block that particular network or that particular interface, so that we can able to control the traffic flow, and also the recovery management can be utilized to prevent this particular attack. And the next one is how this particular ALML is going to, that is artificial intelligence and machine learning, going to helpful in adaptive access. So so here we are going to utilize the concept of behavioral modeling. So we need to understand the behavior of our network with the help of the logs that has been collected from various network nodes. And so from the network traffic, we can able to understand the behavior of the network. And based on the behavior of the network, some interface we can able to block the access, so that the other network can utilize the server access or the network facility as such. So in that way, your ALML has been going to provide services to the adaptive access. And it is going to be useful in vulnerable detection also. So there is a concept of zero-day attack. So what does zero-day attack is means, like, see, we will be having already some set of attacks we have seen. So these are the normal set of attacks that has been available already, so that we can easily predict. So zero-day attack is one thing that has been like, it has been created instantly by, or a new attack that has been entering the network without any signature or without any sign that has been there. So for that, the user or any of the services provider have to launch any type of service package or a security package to be created, and should be launched to stop these particular type of attack. So in that scenario also, we can utilize that is artificial intelligence can also be utilized. And there are two categories in which we can able to utilize this particular artificial intelligence. One is in the defensive type, and other in the offensive part also, we can go ahead with utilizing this artificial intelligence. So in case of defensive artificial intelligence, so some of the things that has been utilized over here is that the malware detection. So in malware detection, artificial intelligence can be utilized. Anti-spam identification, we can go ahead with utilizing artificial intelligence. Data classification, vulnerability management, and threat intelligence also, we can go ahead with utilizing artificial intelligence. So what is there in the offensive part is that malware creation, smart botnets, spear phishing, and conditional attack also. This hacker can utilize artificial intelligence to create all these type of attacks over there. And finally, with the application of AI. So what are the various applications that has been there with AI in cybersecurity when we consider cybersecurity? First one is secure user authentication. So how this AI is being utilized over here is that, so user authentication. So when we talk about a particular organization, there will be some set of patterns that will be followed for the user authentication or the user access. So if the user is not using such a type of pattern, it's been predicted, yeah, like, yeah, he is not a legitimate user, or if he is trying for more than some of the threshold amount of time, if he is trying, And if it is not matching with the pattern of the organization, it can be easily predicted with the help of AI, that is, he is not an authenticated user, but someone who is trying to utilize the organization content or trying to getting the access of the data. The next one is botnet detection. Botnet is nothing but the infected system or the set of system that has been infected. So with the help of AI, we can able to predict the machines which has been infected and has been not infected, and we can safeguard the system that has been not infected by viruses. Then hacking incident forecasting. So with the help of AI, we can able to understand how is that the hacking is going to be forecasted or it's not going to be forecasted. With the behavioral pattern of our system, behavioral pattern of our network, we can understand, this type of packets has been entering our system. So there is a feasibility of the hacker might attack our system. So with the help of AI, we can able to predict in prior whether the hacking is going to take part in the network or not. The next one is the network intrusion detection and prevention. Network intrusion detection. Whenever we are having a network, of course, the router will be playing a major part in providing the communication. So it's like a firewall. It's going to stop the unwanted or the malicious packet that has been getting inside the system. So what normally AI will use here is that it can use any ML technique or any type of classifier can be utilized over here. And with the help of the data set, we can able to understand or we can able to train that particular model. And with the help of the data set, we can able to understand when a particular packet has been reaching a particular network, we can able to classify whether this particular packet has been malicious or if it is not malicious, or whether this particular packet is supposed to be allowed to get inside the network or it's to be stopped over here itself. So these type of intelligence can be utilized in the network so that our network will not get affected by malicious contents. Then spam filter application. So this is basically in emails, there will be n number of things will be entering our inboxes. So we can able to predict the spam email and the normal email, and we can able to stop this particular spam email to get inside our inbox. So in that also AI will help. And of course, the fraud detection can also be done with the help of the AI in the field of cybersecurity. So what I wish to say here is that everyone should be secured, and whenever you're using your cell phones or your laptops or whatever devices you're using it, so you should update your content, you should frequently change your password. We can use this AI type of applications to earlier predict these type of attacks or these type of malicious content to get inside our system, so that we can prevent the attack there itself. Yeah, thank you so much. Thank you all for joining.
Thank you, Ms. Priya. Thank you for giving, thank you, Ms. Abirami. Thank you for sharing your perspective on artificial intelligence pertaining to cybersecurity. It's a question and answer session we have now with pertaining to Ms. Abirami. If there are any questions, please post or please unmute your hand. Yeah, you could make use of this time. We'll just give a couple of minutes if somebody has any questions, ma'am.
Yeah, sure.
I have a question.
Yeah, Dr.
Yes.
Is it possible for someone to know how to just scrub their computer, purge the computer, and then just reload, like new programs to get rid of the infections that are there in the system? Because I do have malware in my system, but I don't know how to get rid of it. And I was thinking if I just purge the computer and start all over with a new password, that might help.
Yeah, see, whenever data has been entering our system, so the system, the data has been entered into a system in the form of packets. So how this AI is going to be helpful over here is that it can able to collect the packets that has been entering our system, and it's going to classify that particular packets, and we can able to, with the help of the data set, we can able to understand whether it is a normal packet or a malicious packet. And if it comes under the category of malicious packet, it can stop the system to allow this particular packet to get inside the system.
And that AI, is it available free of cost, or you have to purchase it?
We can create, there are some set of tools that has been freely available also, or we can create our own applications. There are a number of data sets that has been freely available in the internet. So you can utilize any of the models, any of the machine learning classification models, and we can utilize this particular data set, and you can make use of that, and you can classify the contents.
Thank you.
Thank you,
Any other
Thank you,
questions?
Abirami.
Yeah.
Yeah. Do we have any? Okay, we have a question. Is computer becoming so slow as a result of malware?
Yeah, it might happen. Like it depends upon the type of malware that has been injected. It might even slow down our systems. Yes, it happens.
Okay. Okay.
Valediction.
So sorry if I interrupted you.
No, we'll go for valediction. Thank you.
Okay. Okay. Thank you. Thank you all for the time today. First of all, I would like to thank our speakers who've made their time, taking their time rather, and sharing their expertise on this topic, artificial intelligence, and having an in-depth presentation on the topic chosen by them. And I would like to thank all the participants who've been part of this program, so enthusiastic, having a lot of questions answered. And it's been a real learning session for all of us. I hope it has provided a rewarding experience, just like I had and all of you. Despite the time zone, and we are located in various parts of the world, you've made your time and you've joined this session. We really appreciate it, and we look forward to have future sessions. And these participations really motivates us to have further sessions like this. So thank you.
Certificates.
And yes, the certificates would be shared by an email after the session. And if there are anything further, you could also write to us on the worldresourceswebinar@gmail.com. So we have already shared the email ID. So if any further clarifications pertaining to the session or in terms of your participation certificates, please feel free to write to the email ID.
Thank you. Thank you. Priya, thank you everyone. Okay.
Thank you all.